We now dig into the textbook from the Council for Six Sigma Certification, the CSSC. And the first three chapters support your white belt certification, mainly focusing on Six Sigma. And recognize that you do have multiple options to learn the CSSC text content, such as you can actually read the text itself, or you can watch and or listen to the videos, which are my interpretation of the text. You can also read the scripts from those videos, or you could use those in combination. However, you can best learn the material. Just recognize the videos and scripts generally mirror the flow and the ideas of the CSSC textbook. And some of you may already have Six Sigma knowledge from earlier coursework or training. However, we'll assume that you do not. And even if you do, this will still be a good review and affirmation of your knowledge. So we'll start with chapter 1, what is Six Sigma, which includes data-driven processes and decisions, defining Six Sigma, common Six Sigma principles, and the challenges of Six Sigma. Recall our definition of quality: consistently meet customer value expectations. That is, understand what customers expect relative to cost, durability, speed, convenience, customization, and other value characteristics, then deliver on those expectations over and over again. So this applies to both products, meaning tangible goods, and services, intangible acts. And the opposite of consistency is variation. Variation is the killer of quality because it leads to defects, meaning that customer expectations have not been met, which means lower customer satisfaction. So Six Sigma focuses on reducing variation, reducing defects to improve quality and customer satisfaction. Likewise, our process costs, meaning the cost to execute a process to serve a customer, may also decrease. With this approach, Six Sigma includes both a methodology for finding variation to improve a process via DMAIC, define, measure, analyze, improve, control. That's our recipe to improve processes. And then number 2, statistical evaluation of the variation of a process. As we'll see, a process that has achieved Six Sigma quality is virtually perfect, meaning mostly defect-free. So in the end, Six Sigma is a win on multiple levels. We can reduce process variation, which means increasing consistency, having fewer defects, and that will lead to higher quality, which improves customer satisfaction and lowers our organizational costs. Many organizations and employees tend to rely heavily on their intuition and experience to make decisions. Now, intuition and experience are always important. However, we should also simultaneously pursue facts and evidence. So Six Sigma is data-driven, meaning that it relies on measurements and metrics. It does not negate the need for intuition and experience. Rather, Six Sigma supports that with evidence. In other words, Six Sigma urges organizations and employees not to rely solely on intuition and experience. With Six Sigma, changes are based on rigorous analysis and testing before implementation. The text highlights how Six Sigma sometimes applies beta testing, which means implementing changes with a select group of customers, products, and or services. That is, test the proposed changes in a small-scale controlled environment rather than roll them out to the entire organization and all of its customers at once. We'll quote directly from the text here on how Six Sigma approaches improving processes. Specifically, Six Sigma lets organizations identify problems, validate assumptions, brainstorm solutions, and plan for implementation to avoid unintended consequences. The goal is to be more certain about the outcome of the changes, including controlling the improved process to make sure that the improvements stick. Again, Six Sigma refers both to a methodology, meaning an approach to improve processes via DMAIC, and a statistical level of quality that is virtually perfect, with 3.4 or fewer defects per million opportunities, DPMO, which means 99.99966% defect free, almost no defects, virtually statistically perfect. In comparison, 1 sigma below, a 5 sigma process is 99.97% defect free with 233 DPMO. That's still really good and may be acceptable in some organizational settings. Still, that's a lot more defects and subsequently more dissatisfied customers than a Six Sigma process. For instance, the text describes the difference of Amazon operating at a 5 sigma versus a 6 sigma level of quality. And we all know that Amazon processes a lot of shipments every day, with the peak being Cyber Monday after Thanksgiving, millions and millions of shipments. Suppose that a shipping error, meaning a defect by Amazon, costs them $35 to resolve. If they operate at a 5 sigma level of quality, they have $300,000 in error costs that day. But a 6 sigma level of quality is only $4,400 in error costs. So we see a marked difference between the 5 sigma and 6 sigma level of process quality. Improving to 6 sigma saves about $295,000 that day alone. And lower sigma levels, meaning lower levels of quality, are much, much, much worse. 4 sigma results in $8 million in error costs. 3 sigma means 86 million in error costs. 2 sigma is 397 million in error costs. And then a 1 sigma level of quality means $889 million in error costs in one day. So even if we can't get a process to a full 6 sigma level of quality, any improvements can greatly benefit the organization. We can determine the sigma, the quality level of a process, by calculating the process yield. The yield is the percentage of good outputs. And the calculation is the number of opportunities, basically how many times the process executes, minus the number of defective outputs, defects, divided by the number of opportunities. With the process yield, we can then use the DPMO table, defects per million opportunities, to derive the process sigma from that yield. For perspective, the sigma represents the variability in a process that we'd like to minimize or at least reduce. And a higher process sigma means fewer defects, a lower DPMO, and higher process yield. Let's try an example with a printing process that has 150,000 opportunities each week, meaning that it prints 150,000 items every week. In this past week, 750 of those were defective. So the calculation is the 150,000 opportunities minus the 750 defects divided by the 150,000 opportunities times 100 gives us 99.5. That means the process has an estimated 99.5% process yield, which means 99.5% defect free. We can then use a more detailed DPMO table to determine the process sigma for this 99.5% process yield. It falls close to 4.1, meaning the process sigma is 4.1, which is fairly good. It's not Six Sigma, but it's fairly good. The text emphasizes how the sigma of a process provides a high-level view of how the process is performing. However, that sigma alone is not enough to decide if one process or another should be targeted for improvement. That is, the organization should not necessarily just fix the lowest sigma process. And they provide some examples of different opportunities. And they say that organizational leadership should also consider the cost and resources needed to improve a particular process versus the estimated impacts of improvements to the process, including cost reductions and/or profit improvements relative to customer satisfaction. The text next presents several principles of Six Sigma, starting with customer-focused improvements. Improve the value delivered to our customers. And that includes determining the voice of the customer, the VOC, which means detailed customer expectations. And then we meet these expectations over and over again in order to maximize customer satisfaction, as well as promote loyalty and retention. And then the voice of the customer can also point to additional features that customers are willing to pay for and prioritize the development of products and services, including new ideas. Value streams represent the sequence of all items, events, and people required to produce an end result, such as a product and/or service. And then a value stream map is a pictorial representation of that sequence. It's a high-level view of the total flow of materials and information, meaning the entire organizational production process. And this includes identification of value add versus non-value add activity. And we'll learn a tool called Tim Woods later to do so. And then ideally, we remove the non-value add, that waste, to improve the process. The second Six Sigma principle is continuous improvement. That means the organization never stops improving. Once we improve a process, we move on to improving other processes. And we keep improving the sigma of processes closer and closer to that perfect level of 99.99966%, virtually defect free. We never stop improving. Continuous improvement. Then the third principle is variation. Reduce process variation. Recognize that all processes have variation, but if we reduce the variation by eliminating the underlying causes, we can improve consistency, which reduces process costs and improves customer satisfaction. Then a related principle at number 5 is removing waste, known as muda in Japan. That represents items, action, or people that are unnecessary to the outcome of a process. And you see that key word is unnecessary. So removing waste is the focus of Lean, which is also called the Toyota Production System, or TPS. And the text maintains that Lean goes hand in hand with Six Sigma. In fact, your certifications will be Lean Six Sigma, combining the two concepts. Then number 6, equipping people. That means that people are equipped to monitor and maintain process improvement. And this includes the idea of total involvement. And then finally, at number 7 is controlling the process. We bring the process back within a state of statistical control and then ensure the process remains in control. The text also presents several challenges with Six Sigma. And overall, they're warning us that Six Sigma requires patience and commitment. It may seem expensive and overburdening and even unnecessary, particularly in small organizations. However, the ultimate benefits of Six Sigma can pay back the upfront investments by improving processes. So the saying is quality is free. Well, quality isn't directly free, but in the long run, it can be considered free, though, because fewer defects, reduced costs, and improved customer satisfaction offer a positive return on the initial investment in Six Sigma. The first challenge is lack of support. Six Sigma requires support and buy-in at all levels of the organization. And again, we call this total involvement. Leaders and executives support the quality culture and provide resources. Subject matter experts share information about their processes with the project teams. And then employees at all levels embrace the idea of change and improvement. So we seek to avoid or overcome leaders who don't understand Six Sigma, including the detailed approach and benefits, and then leaders and employees who lose interest before projects are complete. And then also employees who are fearful of change, including perceiving that Six Sigma focuses on pointing out their problems, making them obsolete, or making their jobs harder. And then we also want to avoid or overcome employees who are overfocused on their own processes and needs while not engaging in big picture, meaning organization-wide thinking. The second challenge is a lack of resources, including money, and then employee availability, meaning their time, and then overall knowledge. The general challenge is that in most organizations, process improvement projects occur on top of employees' full-time jobs. So it winds up being a side hustle or extra work for them. So it can be difficult to pinpoint the best time to start a process improvement project. For instance, when business is good, everyone's too busy keeping up with that higher demand. And then when business is bad, everyone's again too busy scrambling to increase that demand. The number 3 challenge is poor project execution. That is, leaders and employees may abandon Six Sigma methods if the first project or improvement falls flat. So Six Sigma is a significant upfront investment with projects lasting many months or even many years. So an underwhelming project can be extremely deflating. But teams can improve the chances of Six Sigma success by executing the DMAIC project phases correctly and rigorously, as well as choosing low-risk, high-reward improvements for the first-time projects. The number 4 challenge is data and analytics issues. Six Sigma relies on data. It's data-driven change. However, access to accurate data and then properly applying statistical analyses can be difficult, particularly if, say, a process metric is not being captured, or data has to be captured manually, or automated data capture brings in too much information, so it's information overload. or data that is skewed due to assumptions or incorrect capture, or maybe industry or company rules make it difficult to access the data. And the last challenge concerns using Six Sigma in a specific industry. So Six Sigma originated in product manufacturing at Motorola, but it really applies to all industries, including products and services. It can be customized to any industry as well as any organization.